at a constant rate. That's the word that should stick out. Constant. Does anybody have another word that they would use when you see the word constant by any chance? Add with equally between y's. What about constant means linear, okay? Constant means a linear function that is constant because of its slope, it's m. That means that it has to have the same difference between points. Good morning. So each one of these situations we're going to talk about. You don't have to do the math. I just want you to see the breakdown of each problem. Okay, so what happens? Okay, there we go. So first part, this is A. Mark's starting salary is $10,000 and increases by 6% each year. I'm not going to even lie to you. This fooled me. Constant means it's the same. So 6% turned into a decimal is 0.06. You don't have to worry about this. All right, so I'm going to do the math over here. 10,000 times 0.06 gets me 600, okay? Now, I would have to add this to the 10,000 and then multiply again by 6%. So if I did 10,600, I know you can't see this computation, but it's 636. So you see even right there, the common difference you can already see is not going. It's not even 600 here for the second one. So this means that when you're increasing by a percentage, it cannot be constant. All right, because the rate will be the same, but the amount of change per year in this situation would be different. Secondly, B, Mark's starting salary. Yes, Aaron. Yeah. Yeah. Whenever they're talking about salaries and increasing by percentages, or they're using the word commission or increasing or decreasing, it's most of the time going to either be the compound interest formula or the exponential formula. Secondly, B, Mark's starting salary is $10,000 and increases by $1,500 each year. Okay, so he started at 10,000. Welcome, Mr. Kerr. Make sure you sanitize your hands. So the first year he's made 10,000. Second year you added 1,500 to that. Okay, so that means that first year he made 10,000. All right, he got a raise of 1,500. All right, each year you can see that what's being added to the overall amount would be the same. It is constant. So even if, let's say 11,500, 500 plus 1,500, 13,000. So like even if the number of overall amount of salary is changing, what am I adding that's constant each year? $1,500. So B is going to be the one that's constant because it's the one that's the same. It changes the same exact way each year, okay? This is the reason why. Constant, same. When you hear constant, you should automatically think linear, same change. If it's not constant, it can't be linear. All right, so let's look at C real quick. C, Mark's starting salary is 10,000. He receives $1,500 raise after 1 year, and then a $1,600 raise after the second year. That automatically, the first year you get $1,500, second year you get $1,600. That's not even the same. It's not constant. They're just checking to see if you understand the word constant. Lastly, there's another percentage there. If you see percentage, 100% cannot be constant. Okay, and they even change the percentages after the first year. So this is an interesting problem because if you just remember, if they're trying to say that percentages are constant, not true. It has to be the same amount each single time that you're adding, in this case, to the salary. Okay, so this is also wrong. All right, so what's our answer? B. Very good, chat. So I'm going to review yesterday's work quickly, and then we are going to talk about today's work, and then I'm going to let you guys off to do the good works for today. So yesterday we compared properties of two functions in different ways. After second period, I started to give them a different quizzes. I want to give you the same quizzes, but I want you to, it would be hard to complete both in the same period. All right, what I want to focus on is the different ways that they can represent information, okay? When I'm comparing functions, they can write it algebraically, they can write it graphically, they can do it with an XY table, and they can also do it with a word problem, like function D. All four of these circumstances are talking about linear functions, all right? And this is what I would like for you guys to be able to do before the EOC. It would make my heart happy to be able to determine from, like function A, this is a function, y is equal to negative 3x plus 2. If you could look at that and say, that's mx plus b, I know that's linear. All right, I would be a little bit happier if you could go, all right, the first point I would graph is 0, 2. And then my slope from there would give me the next couple points. That would be like the best algebraically that I could get from you. All right, graphically is looking at it, and if you see it's a straight line, you understand that it's linear and that there's a y-intercept that crosses the y-axis. What I would really, really like for you to do is to be able to identify that it's linear, and if you could write a function based off of this graph, where all you need is the intercept and you need the slope, okay? So to go from a graph to equation is what I would want. And from a table, I would like for you to be able to determine if it's a linear function. We do that by finding common differences, like over here. If I find the differences between my y's and they match in this first common difference row, we know it's linear. All right, it's constant change between our y's, and we know that that's linear. And secondly, because of this table, if you could identify when there is an intercept occurring, that would be another thing that I think would be super important to know. Lastly, out of a word problem, how do I figure out how to even write the equation when it's a word problem? That's where I want your mind to be with like this fourth part, this D part. They gave us 2 points. I would find my slope. They gave me an intercept. I would be able to write my function from this. Okay, so we can practice this. I wish I had more time to go through this. This was some of the stuff that you guys got robbed of when last year occurred, okay? So like these are things that are super important to know, and I want to help you get there. We're going to get a lot of review in. I know it's a lot going on right now. I appreciate you guys working so hard, all right? So let's talk about what today is all about. Yesterday was brain hurty, all right? There's a lot going on. You had to read, you had to compare. It was hard, all right? Today, this is going to be transformations. B-FB.2.3 is all about transformations, okay? Now, transformations are when you take any type of function, okay? So in this case over here, I have a quadratic, but it can be linear, it could be quadratic, it could be exponential, it could be absolute values. It doesn't matter what parent function it is, which I'm going to make sure to get across to you. These are the transformations. All right, you can move left or right on the x-axis. It can move up or down on the y-axis. It can reflect over the x-axis or flip upside down. It can stretch or compress, meaning get fatter or get skinnier. You guys don't have this yet. All right. These are all transformations. When you take a parent function and you transform it in some way. The reason why they only use f of x is because all parent functions use the same situations or spaces as I've taught you to understand what type of transformation has occurred. All right. So these are the spaces for transformation. They can give you any parent function, and if there's a negative in front of that parent function, it automatically reflects over the x-axis. Doesn't matter if it's a straight line. If I put a negative in front of it, it's going to reflect it over the x-axis. All right. With the letters in front, in this case, they're going to use K for each one of these spaces. They just don't want to use it here. The letter in front will dictate if it's going to get skinnier or fatter. All right, and once we get you guys going, this board right here explains everything you need to know, and I'm going to answer every question that you have as you're working through the quizzes. Sorry, it's edulastic. All right, if there's a parentheses on the inside of a function, you're moving left or right on the x-axis. If there is a number that's being added or subtracted on the outside of the function, it's moving up or down on the y-axis, okay? Let's go over a couple problems. Now, this is in your notebook, so please go ahead and take your notes out. Open it on up to the first problem if you don't mind, because you're also going to use these as examples as we go along. So, what type of function is this? Linear function, okay? The parent function for this is y is equal, f of x is equal to x. Y is equal to x. All right, that is the parent function in this situation. So what they want us to do is to take this function, which is f of x is equal to x. All right, whenever they say f of x from now on, in this problem, you are going to think linear function, just in this problem. Let's look at what the question asks us. Describe how each of the following functions compares to the graph of function f of x, okay? So what we do is, this is the new function that they're talking about, g of x, and they have a plus 3 on the outside, all right? If they have a plus 3 on the outside, you have to think about your spaces. There's a plus 3 on the outside. So if I have a plus, a number on the outside, I'm either moving up or down on the y-axis. If it's a positive, I move up on the y-axis, okay? So what they say is describe how each of the following functions compares to the graph of the function. So g of x would just be a function that was moved up 3 units on the y-axis because of that plus 3. So that's what we're going to say. Move up 3 units. And this is how you will respond to these type of problems. 3 units on y-axis. Don't make fun of my writing, please. It's silly, but effective. All right. So if a positive number on the outside of a function causes you to move up on the y-axis, what do you think a negative number causes to occur? Yeah, so what do you think number 2's answer is? Yep, move down 5 units. I'm going to spell really good. On y-axis. Okay? This is a transformation of the y-axis for this linear function. So again, if you have a positive or a negative number on because think about it. This is y equals mx plus b. If you didn't have a b, your intercept will always be at 0. The second you have a b, that's your intercept. It moves it up to 3. If you have a b that's a -5, it makes your y-intercept -5. It makes sense. Okay? Let's try this next problem. These are transformations of a linear function. All right, let's do this next problem real quick. What kind of function is that? Want to say it again? What's the smiley face? Parabola, and or we can call it a quadratic, okay? So now, if you have, let's just look at what they're telling me right here. When they say that says x plus 3 squared, all right, there's 2 transformations that they're talking about here. We just figured out from the last problem that when you have a number on the outside of a function, if it's plus or minus, you're moving up or down, right? So they just combine 2 things. The second part, what they're trying to do, when they put a parentheses and then a plus or minus on the inside of the parentheses squared, what they're saying is you're going to move left or right. Okay, so let me give you the simpler version and then we're going to combine the 2. So if you were given x minus 2 squared as a function, on the inside of parentheses, it's always going to be left or right. It's the opposite though. So if it's a -2, you're moving right on the x-axis too. All right, so if there's inside of the parentheses, it's left or right movement. So now you have a number on the outside that moves it up or down on the y-axis, and then you have the +3 on the inside that moves it left 3 units. Okay, so that's what we're going to say. The +3 left 3 units on x-axis. Thank you for playing along, x-axis. And then down 2 units on y-axis. And after you write that out, somebody try to attempt to do this second problem here. There's 2 spaces that we have to deal with. It's very similar to the problem above it. How would I answer this problem below if it's x - 4 squared? You know it's a quadratic because it has that squared. Okay, as long as it has a squared, you know the shape of the function will always be a parabola. So somebody tell me, what's the transformation that occurs on this second problem? Okay, so I heard right 4 units on x. And Aaron, what about that number on the outside?
Up 6 on the y.
And up 6 on the y. Right 4 units on x, up 6 units on y. Okay, we got one more problem, and then you guys got a edge elastic to start. So actually, just in case if you don't have a computer, I'm going to find something else too. All right, 30 more seconds. I want to give you enough time to get this work in. Huh? I can't. To be honest, I just take the problems that I think will teach y'all straightforward, and I make all these myself. Not the problems per se, but I put together what I think is going to show you guys the most. Sorry. 30 more seconds, and we got to move on. People are falling asleep. Those are the standards that those letters have meaning, but I'm not smart enough to tell you what. I know F means functions, but all right. So let's try this last one. Remember, it's all. Oh, there's. So this is what kind of function is this called? Quadratic. This is what a quadratic function is written like. Okay. So if I can identify the quadratic shape, I know it's x squared, but it's flipped upside down. So the way that we flip a function upside down is we put a negative in front of it, okay? So they want us to write the equation for the function. They want us to guesstimate. We can't really tell per se exactly, but it flipped upside down on the x-axis, so that's a negative x squared. And then let's think about this space right here. When you have a positive or a negative number on the outside of a function, you're moving up or down on the y-axis. Does this look like it moves down on the y-axis or up on the y-axis? Down, so it's 0. And we could even, let's just say it would show that you understood if you put like a -2 on the outside, because what that shows is that you know that it's not at 0, 0, which is where parabolas normally start, sorry. And it's moved down more than 1. So that's pretty much a guesstimation of this. The negative in front of any function always makes it reflect over the x-axis. And too much. All right, so here's the deal. That is your edge elastic. It's in vPortal. There's 2 things that I'm going to ask you guys to do. All right, if you can get them both done this period, you'll get some extra credit on your quiz on Friday. Okay? You can finish it by the end of the day, but you have to do the quizzes first. Oh, wait, yes. So you have two that you need to do. EduElastic is also in vPortal. You might just need to add it. Okay. These are your two codes, 960740. And then this is the class code for EduElastic that you'll add. All right. EduElastic, I'll put how you spell it top right. Oh, come on, let me write. Please. I'll write right here. So it's EduElastic. So for the rest of the period, you guys are going to pull your phones out. Yay, start that quizzes. Give me 1 second, I'll put that thing right back up. Give me 1 second. Okay, there's the code. And the second assignment is in something called EduElastic. I'm sure you guys have all used it before for at least a test. EduElastic. So you're in vPortal. All right. So you have the rest of the period. You guys have about 25 minutes. You guys have any questions about what I expect of you for the rest of the period? You guys are always so quiet, and that's okay, I guess. All right, good luck, have fun. Let me know if you have any questions.